In this class, we're going to consider number types. So when you first learn to count, you just see this big collection of numbers and you know that all the numbers belong in there. So every number you've ever seen is part of this collection. And you contrast that with things that are not numbers, like letters, for example, the alphabet. But it becomes useful later on to take all these numbers and start to subdivide them into different categories. And each of those categories of numbers has got a name. It's a type of number, what you might call a number system. And we basically are going to look at those number systems in this class today. So the different families, the different types of numbers that you get. So there's two broad categories of numbers. So the first category is the one that you're already familiar with, and that's the real numbers. Okay, and the real numbers includes basically every number. So positive, negative, large numbers, small numbers, a number pi, decimal numbers, fractions, square roots, everything is in there. But the contrast to the real numbers is what are called the complex numbers. And the complex numbers you might have heard of, you might have seen, but they're probably at this point a little bit vague to you, if not completely off radar. You may never have heard of these. So the complex numbers basically is everything that's not a real number, and the real numbers is everything that's not a complex number, okay? So I'll elaborate on this in a moment. I know it seems strange, but this is basically our big division here. So we can call these our two kind of categories, I guess, of numbers. So the real and then the complex. So we're not going to get into it too much, but the complex numbers are basically imaginary numbers. So I can put kind of a subcategory, I suppose, under here, just to kind of note that these are imaginary numbers. So imaginary numbers are built from what's called the imaginary unit. And the imaginary unit, which we call I, is equal to the square root of -1. So in the same way that we tend to build, all our counting numbers from the number 1, because every number is just a collection of ones really added together or subtracted, so for the whole numbers. And that's how we build some of our whole counting numbers. In the same way, imaginary numbers are built from this thing called the imaginary unit. And it's kind of called imaginary because you cannot actually take the square root of -1. So it's not a real number, basically. Real numbers don't have square roots for negative. So we have to categorize these guys over here. Now it turns out that these are actually really useful and very applicable to the real world, even though they're imaginary, which seems kind of strange and counterintuitive, but they've actually got a lot of real world applications. And it turns out that we could actually think of these numbers as being a subset of these numbers. Maybe these are the actual numbers. Don't want to talk too much about that because you'll probably be taking a course on that in the future anyway, but I just want to set up the contrast between real and complex numbers and to highlight that these complex numbers are imaginary numbers and they're built out of this imaginary unit. So we'll call this the imaginary unit. Okay, so we'll just park that, and if you're curious about that, you can look into complex numbers a little bit further. They basically allow us to solve equations that we cannot solve in the real number system. Now these number types, these number systems all have a way of notating them without having to write out the word. And basically for the complex numbers, we just have this sort of fancy C. For the real numbers, I'll put it here, we've got basically a kind of fancy R. So you'll see these quite often written in math textbooks. You'll see them in math questions. It may say something like find a solution in R or something like that. And this is the point of this class today, is just to get you familiar with these so that if you do see them in question types, you don't freak out and think, what does this scary, weird looking R mean? It doesn't mean anything special other than, hey, these are just real numbers that you're working with. So there's a bunch of subcategories of the real numbers, and we'll start to work through those now. So probably the first one to look at would be the integers. So the integers are basically just all the whole numbers. So the positive and the negative whole numbers, and we notate the integers with a kind of Z, I guess. I'm not quite sure where the Z comes from, but that's how we notate the integers. You'll probably see that one quite a lot. If you want to notate the positive integers, you can put a little plus on it at the top there. If you wanted to notate the negative integers, you would put a minus. So that would be all the positive whole numbers, all the negative whole numbers, okay? And those are the integers. And then we've got a category called the natural numbers. And the natural numbers are basically the counting numbers. So when you're counting, you do use the integers, but we tend to count with positive whole numbers. So the natural numbers, which are notated with like an n, all of these just have basically an extra line in them, don't they? They've got like a line that makes them look all fancy and ornate, but it's effectively just a letter with an extra line. So the natural numbers are just basically the positive integers. Okay, they're just your counting numbers, effectively. Okay, then another category are the rational numbers. So these are quite important. You'll see a lot of this later on. So the rational numbers, which are notated with like a sort of fancy kind of, I'm not quite sure how to draw it, it's like a fancy Q, something like that. That's maybe not quite right, but it's a Q. The Q stands for quotient, and a quotient is like a divisor. It implies division, okay? So you'll see that. And the rational numbers are numbers that can be written in the form of a ratio. In other words, a fraction, a over b, where a and b would be integers. So if you can write a number in a fraction, then it's a rational number. So for example, the number 2 over 3. Or it could be a whole number. It could be, say, the number 4, but we would write the number 4 as 16 over 4. That's still a rational number. And these guys are contrasted with their counterpart, which is the irrational numbers. A good way to think of these actually is that the rational numbers, if you ever have a rational number and you put it in your calculator, it would either be a whole number or it would be a decimal number where the decimal ends after so many decimal points, or it repeats on a regular pattern forever, whereas the irrational numbers, their decimal expansion, like all of their decimal numbers, just go on forever and they don't form any particular pattern. So these are the irrational numbers. I'm not quite sure if they've got a symbol. I should really know that, but I don't know. I don't think they do have a symbol, but the irrational numbers are just contrasted with the rational numbers. Okay, so they're numbers which by definition you cannot write in the form a over b. And if you ever get into math classes where you've got to work more closely with these, that's what you'll do to prove that a number is irrational. You'll prove that it cannot be written in that form, because by definition, a rational number is this. So therefore, by definition, an irrational number is one that cannot be written as a ratio like this. Okay, so that's just giving you a bit of an overview, basically, of all of these different number systems. And like I said earlier, there's no technique to learn here. It's just a case of trying to memorize the categories. And I would say the big thing here really is to learn this subdivision between real and complex numbers, and then just to start to feel your way into learning these guys here. As you start to work with more complex math problems, you'll start to see questions that rely more upon these definitions. So at the moment, you don't need to think too much about the intricacies of these, but at certain points in time, you might need to start to think, well, where do these number systems overlap? Like, where does a rational number become a natural number, or, you know, vice versa? There might be some intricacy to the question that you're working. But that's basically the overview of the different number types that you get. So spend a little time just trying to absorb those, and just make sure that they make sense to you and that you can give examples of different types of number.